United States Army is designing a new strategy to upgrade its short-range air defense M-SHORAD system in response to the dynamics of modern warfare, particularly based on experiences from the conflict in Ukraine. Developments in air threats, such as the increased use of unmanned aerial systems, UAS, roaming munitions, as well as other low-altitude air threats, demonstrate the need for more sophisticated and adaptive defense systems. Today, unmanned aircraft, both military and commercial, are increasingly used in both kinetic and non-kinetic operations. Therefore, the U.S. Army is adjusting the development of M-SHORAD to meet these increasingly complex challenges. System updates will ensure that air defenses remain effective in the face of increasingly unpredictable attacks. M-SHORAD is a key element in the U.S. Army's short-range air defense strategy. The system is designed to counter a wide range of threats, from helicopters and fixed-wing UAVs to short-range ballistic missiles, and is being developed in phases to ensure capability improvements match the evolution of the threat. In the first phase, the U.S. Army targets the deployment of 144 M-SHORAD increment, 1 units to 4 battalions, with each battalion receiving 40 units along with support vehicles and personnel. In 2021, the first units were delivered to the 5th Battalion, 4th Air Defense Artillery Regiment, and reached full operational capability by the end of 2022. M-SHORAD Increment 1 is built on the chassis of the M1126 Stryker combat vehicle and is equipped with a variety of weapons, including 2 AGM-114L Longbow Hellfire missiles, 4 FIM-92 Stinger missiles, a 30mm automatic cannon, and a 7.62mm caliber M240 machine gun. A multi-mission radar is also embedded to detect ground and air threats. However, due to concerns regarding the wear and tear of Hellfire missile launchers, the U.S. Army plans to replace them with a second Stinger missile pod, so that each vehicle will carry 8 Stinger missiles. In the next phase, Increment 2 will introduce a 50-kilowatt directed energy laser system, which is expected to counter threats from drones, rockets, and artillery. Although it has been tested since 2019, the effectiveness of this laser is still being developed to optimally deal with various threats. A final decision on the system is expected to be made in 2026. Meanwhile, Increment 3 will bring the next-generation short-range interceptor, NGSRI, to replace the Stinger missile. The NGSRI offers improved range and accuracy and will be equipped with the XM1223 multi-mode proximity airburst munition to counter both air and ground threats. Lockheed Martin and Raytheon Technologies have been appointed to develop a prototype of this system, with the first demonstration scheduled for fiscal year 2026 and production expected to begin in 2027. In the face of modern warfare challenges, the U.S. Army continues to accelerate the development of M-SHORAD. Incremental improvements, from modifications in Increment 1 to the integration of laser weapons in Increment 2 to the adoption of a new generation interceptor in Increment 3, demonstrate a serious effort to strengthen the air defense system. The next phase, Increment 4, will focus on improving the efficiency and effectiveness of the system to be better prepared for future combat scenarios. Through continuous testing and feedback from soldiers on the ground, M-SHORAD will continue to be adapted to face the changing battle landscape. In development, the M-SHORAD also receives support from artificial intelligence, AI, technology, and advanced sensor systems. AI will assist in early detection and more accurate target identification, while more modern sensor systems will improve situational awareness for troops on the ground. With this integration, response to threats can be faster and more effective. In addition to technological upgrades, training for personnel is also a major concern in the implementation of M-SHORAD. The U.S. Army regularly conducts exercises to ensure soldiers understand how to optimally operate and maintain the system. This training includes combat simulations, system reprogramming, and defensive tactics in the face of modern airstrikes. The U.S. Army also continues to collaborate with allies and international partners to improve the effectiveness of M-SHORAD. This collaboration includes intelligence data sharing, joint testing, and broader integration of air defense technologies. With this cooperation, the air defense system developed can be more flexible in the face of global threats. Going forward, the U.S. Army plans to continue developing new variants of M-SHORAD that can be used in various battlefield conditions. This adaptation allows the system to be operated not only in the ground environment, but also in amphibious and urban scenarios. Thus, the combat capability of troops can be further strengthened. In addition, research and development in the field of directed energy continues to improve the effectiveness of the laser system in Increment 2. Defense scientists and engineers are working to improve the durability and efficiency of lasers so that they can be used longer without performance degradation. The results of this research will be a key factor in determining the continued use of lasers as primary weapons in the future. With these innovations and improvements, M-SHORAD will continue to be a vital component of the U.S. Army's air defense strategy. Regular evaluations, technology updates, and improved operational tactics will ensure that the system remains relevant in the face of evolving warfare dynamics. With this approach, the U.S. Army seeks to remain at the forefront of protecting its troops and strategic interests from increasingly complex air threats.